Hi everyone, my name is Yiyu Chen. I'm a building performance engineer at ZeroNV. In this presentation, I'm going to talk about a parametric simulation tool that we developed in-house and how we have been using it to improve energy modeling workflow and performing early design phase parametric analysis. So here's the problem that we as energy modelers often face. During early design stage, we often get a question from the design team about how they should optimize the envelope design to meet the EOI target. So the key to answer that question is parametric simulation because it will give you so much data to explore. So we now face a dilemma. We have two options. One is to use a simple energy modeling software, which will allow you to quickly build a model and run hundreds of simulations easily, but the results might not be that reliable or sustainable in the long run because it's simplified energy models. Option two is to use a full-featured energy modeling software, which might not be as fast in building a model, but it offers you robust results. So here at ZeroNV, we are an IESVE powerhouse. We always do detailed energy modeling and want to make sure that we can stand behind our results. So we always choose option two. Luckily, thanks to IESVE and its Python API, we were able to develop our own parametric simulation tool within the software. So we can have both efficiency and reliability, the best of both worlds. So here's how the tool works. We have an interface module, simulation module, and reporting module. It all starts from the user interface where you can specify parameters to set up your simulation, and then it proceeds to create constructions in bulk based on your inputs, and then it kicks off the simulation cycle, including load sizing runs and energy simulation. Depending on how many runs you have, it will keep running back-to-back simulation and non-stop until it's all finished. And finally, the reporting module is going to grab all the results to produce graphs for data visualization. So here's a quick snippet that shows you what the interface looks like and how you can set up parameters to prepare your simulation. And here is the back-to-back simulation in action. And the log here will output detailed information on where you are in the process, how much time is left, and etc. And this is the parallel coordinates plot it produces at the end. For this one, we have 1025 rounds. Each column here represents an envelope variable and its corresponding values that we specified in the user interface. And the final column on the right is energy consumption, or EOI. So here's a quick case study. This is a project we just worked on recently. It's a courthouse located in Northern California, 78,000 square feet, and it's in climate zone C3. So the design team was interested in exploring envelope design options during the schematic design phase. So we performed parametric analysis using our tool. In total, we had 1,025 rounds and took about 12 hours. So what we did was that we set up the simulation before we were done for the day and just let it run overnight. The next morning, we came back to check the results. So the EOI target for the project is around 48 or lower. So the first step is to select all the rounds that will meet that criteria. So we have a lot of options to choose from, as you can see. And the architect was planning on designing a window to wall ratio between 40 to 60%. So we selected that range. For glazing solar heat gain coefficient, the design team was planning on designing towards 0.317. Now, just to clarify, that number is what we specified in the user interface. It doesn't mean it has to be that exactly. This number just needs to be within the constraints that the architect was interested in studying, and that applies to all the variables here. So for glazing assembly U factor, the initial plan was to design towards 0.35. And for exterior wall and roof U factors, the design team was considering to reduce the amount of insulation they're putting in them. So it was 0.111 for the wall and 0.057 for the roof. So this is the initial path we identified for the design team, and this is where we are starting with. So at some point during the same schematic design phase, the architect wanted to know if it is possible to increase the solar heat gain coefficient a little bit to make the glass less reflective while still meeting the EOI target. So we reutilized the parallel coordinates plot because all the results were there at our fingertips. We just need to explore them again and no need to rerun anything. So we increased the solar heat gain coefficient, and as you can see, the initial path we identified is gone. So we need to do something to bring it back. So the first thing we looked at was to lower the glazing assembly factor to 0.25. Now this works, however, 0.25 is pretty challenging to achieve. So we want to know if there are other options available to us. So the next thing we looked at was to lower the exterior wall U factor to 0.072. Now by itself, this is still not working, but if we can at the same time lower the roof U factor to 0.038, now we have a new path. So this is eventually what we presented to the architect, and they were very happy with this result. So the whole point of this study is to show you how we were able to utilize our parametric tool to perform envelope optimization and bring the project back on track. So this tool is currently not available yet to the public, but we will consider to make it available in the future potentially. But we do have a detailed demo on our YouTube channel. It's a year old at this point, so it doesn't have all the latest features, but should give you a good idea of how it works. We do have other scripts and tools that we collectively developed in-house that are available for download in IESVE content store. So feel free to check them out. Also, please check out our website, bemtoolbox.com. Finally, just want to give a quick shout out to my colleagues. They all have been doing an amazing job developing the scripts and tools you just saw, so a huge thanks to them. And that brings me to the end of my presentation. Thanks for listening.